the formal way of doing that. However, you'll be glad to know there's a much quicker way, and we don't need to do that unless we are explicitly asked to. So if we have a situation such as this, so y equals a is just a constant, okay, x to the power of n. So for example, if we have like y equals 5x squared, let's say, then to differentiate, what we do is we put that power to the front. That's where we get the n, so na, and then x to the n minus 1. So in other words, we put the power to the front, and then we get the power going down by 1. So 2 times 5, and then that's x to the power of 1. So that's just 10x. Let's do another one really, really quickly. So if I said 8x to the power of 4, you bring the power down. So 8 times 4 is 32. And then you decrease or decrement the power by 1. So it'd be 32x cubed. So x to the power of 5, bring the 5 down and reduce x to the 5 down to 1, but down by 1 power, x to the 4. We have to do this with fractions and things as well sometimes. Doesn't matter. Bring the half down to the front, and remember it's minus 1. So a half minus 1 goes to minus a half, doesn't it? So it will look something like this. 2x to the power of 6. Bring the 6 to the front. Don't forget to multiply the 2 by it. If it looks a bit more complicated, so you're multiplying or dividing, just use power rules. So this is x to the 1 divided by x to the minus 4. Well, that's just x to the minus 3. And you can do this with negative powers as well. Bring it down and decrease the power. So minus 3x to the minus 4. If there are roots, as per usual, we want to convert this to index form. So this is x to the power of 6 to the power of a half. Square rooting is the same as a half. Power rules say that you multiply those. So that's the same as x cubed and 3x squared. Just be aware here, this is all about like x and some power, okay? We couldn't do anything where x is the power up there. We don't know how to differentiate this until next year. But for now, we're just talking about things like x squared, x cubed, but also more difficult things. It could be x to the half or x to the minus, I don't know, 5 over 2 or something. These are the things that we can differentiate using this rule. So pause the video, have a quick go at these. Remember, it's x that we are talking about differentiating each time here. And also just notice the notation and how the notation is changing between the questions. So pause the video, have a go. So 7x to the power of 6, 30x to the 9. Simplify this. So a half minus 2 is minus 1.5. It is easier, though, to keep things as fractions normally at A level. So we keep it as a fraction, something like this. A is just a number, so bring the number down, A times A, and decrease it by 1. Don't be put off by unfamiliar situations, just stick to what you know. This one here, 49x to the 7. Please remember that we apply the power to the number and to each sort of variable, each letter. Yeah, so 7 over, hang on a second. So 7 times a half. Let's just have a quick look at this one over here. This should be 7 over 2, shouldn't it? Yeah, that one there is incorrect. That one should be 7 over 2. Okay, just watch out for that one there, because we have to the power of 7, and then we have a half, so it's 7 over 2. So there's a small mistake in that one there. It doesn't have to just be, by the way, it doesn't have to just be y or f of x or y or f of x. You can do this with other letters as well, and you'll see this coming up later. This might be, for example, about area, and x might be like a length on a shape, and this might be something to do with the area. Okay. How do we deal with situations like this? Well, it's very, very nice. If the terms are separated by addition or subtraction signs, you can actually just differentiate them each as you would expect. A couple of special ones here. So x squared is 2x. We've talked about that. 4x. Why is that 4? Well, bring the 1 to the front and you get 4. Decrease the power by 1, 0. So x to the 0 is 1. That's why this one works. 3. It's sort of like you're doing this. What's 0 times 3? Well, it's going to just disappear. So that's why there's a blank. So this one here, 2x squared. So we're thinking 4x and minus 3. Notice that for this bit, it is a bit like you are just reading the gradient from a line. You're just picking that minus 3 out. Here, we can assume that we're differentiating with respect to p, so p must be a variable here. Notice it says dp. That should be dy over dp, okay? Because there are no x's. Y equals ax. A is just a number, so think about what you would do if it were like 5x, for example, where you would just take the x away. P is a constant here. So this one here, this part disappears, and you bring the 2 to the front there. Okay, so your turn to have a go. Pause the video here, have a quick go, and I would encourage you to think about the connections between these questions as you're solving them. It will help you sort of deepen your understanding a little bit later about what is important and what's not important when you differentiate. Pause the video here, have a go. And answers on the board. Some interesting things that we notice. If you have x squared minus 5 and x squared plus 5, well, of course, you're just shifting them up and down. So the rules for the gradients, it makes sense that they would be the same. Okay, I'm going to put a cut in here, and should we cut in here? Oh no, let's go. Let's finish in a moment. So we've talked now about how you differentiate, but the whole point of this is often to actually get an answer. So find the gradient of each curve. Well, we know that if we do this dy dx thing, we can come up with a rule for its gradient. Let's do that. 3x squared is 6x, plus x is 1, because there's a 1 in the front. Minus 5 will disappear. That's the rule, but what can you actually do? Well, if you're being given a particular point, it's normally the x that you use as well. If you're being given a particular point, so for example here, x is 1, you can actually put that number in. And what does it mean? 6 times 1 is 6, plus 1 is 7. It means at this point on this graph here, the gradient is 7. Let's do one more. So this is the original graph. That just tells you y equals. If you differentiate, this is the gradient function. It can be used to find the gradient on this graph. You'll get 4x cubed plus 6x squared. We're looking at this point here. So the minus 2, we plug it into the x values in both parts. So pause the video again, have a go at the questions here on the board. One thing to be aware of, you will need to expand out this bracket first, okay? Because we want terms separated, sort of like a polynomial format with addition or subtraction signs between them. Especially if you're doing this part here, you need to expand out, you need to simplify. Okay, so some answers there on the board to pause and to check. And I will just very quickly talk about this one here. Remember, at A-level a lot, we have to use rules of fractions backwards. X cubed minus 2x over x is the same as this here. You need to split it up into two separate parts. This is like normally lower down in school, you went this way, but we want to go this way. Then you simplify. So that's x squared on the left. And here, this is minus 2. And then you're ready to differentiate that. So it should be 2x, which is what we've got here. One last harder example. So this is my function of x. This is a little bit like saying y equals. Find the gradient of this at this point. Okay, well, what's the gradient function first? So the gradient function, if you're using this notation, it's f dash x. This is the same as dy dx. Okay, so 4x squared, so that's 8x minus 8. We want to find it at the point a half 0. So you need to put in there a half. The correct way of writing the notation is you say f dash and then you say a half. It means you're changing the x's to being a half. And that equals 8 times a half minus 8. So that's 4 minus 8, so it's minus 4. Okay. Does that make sense? Well, yeah, it could. If you have a quadratic, there are points that have a negative gradient. B, find the coordinates of the point on the graph where the gradient is 8. Well, I know that the rule for the gradient is 8x minus 8. So let's just write that out again. So the rule is 8x minus 8. And here I want to find the coordinates. So I kind of want to find this one where the gradient is 8. Well, that's the gradient bit there. So let's make that equal to 8. 8 equals 8x minus 8. Add 8 to both sides. 16 over 8 is x. So x equals 2. It does say find the coordinates. Okay, so find the coordinates. I should say find the coordinates really, because it is about a point. So you need to just put it back into the original and find the y value. So x squared 4, so 16 minus 16 plus 3. So x equals 2, y equals 3. Let's just double check that one there. So 2 squared is 4. Yeah, that should be good. Okay. Find the gradient of the line at the points where the curve meets is a key word here, the line y equals 4x plus 5. So there's some kind of quadratic or something, and then there's a line. And what does it say? It says the points. So really, I should kind of draw it like this. So there are going to be some points where they meet each other. So the first part is actually simultaneous equations. So where are the points? Let's find the points for part C first. The points are when 4x squared minus 8x plus 3 is equal to 4x minus 5. Take away 4x from both sides, will give you minus 12x. Add 5 to both sides, will give you 8 equals 0. 4x squared. Notice they're all, 4 is a factor of all of them, so you could simplify that. So you could do 4x squared minus 3x plus 2 equals 0. And because you're solving, you could divide it by 4. Okay, and if we solve this one here, it's going to be minus 2 and minus 1, isn't it? X minus 2, x minus 1. So we need to find the gradient at the points at points x equals 1 or x equals 2. And I think we've already done x equals 2. Let's just check the neat working out for that one there. Okay. So the final thing is we put 2 into our gradient from before, and we got 8. That's exactly the same as, where did we do that? That was exactly the same as b. Okay, so that's a little bit repetitive. But this one is a new value. So you put x into the gradient function. This here, that's the gradient function. So 8 times 1 will be 8, minus 8 will be 0. Okay. Pause the video, have a go. Very similar question there on the board. I'm assuming you've done that. Differentiate first to find the gradient function, 2x minus 4, and then put the x value in. You get minus 2. Find the coordinates where the gradient is 5. So this is like a backwards question. Remember, the gradient function, okay, comes from this one here. So if we're talking about the same graph each time, we can just keep using this one here. This is about coordinates. This is about gradient. And if it says a coordinate, then you need a coordinate, not just an x value. And finally, a simultaneous equation to get 2 x values, and then you plug them into the gradient function again. Okay, time for you to have a go.